mainly just algebra and a little bit of a review from algebra 2. So today we are doing operations with functions. So for the first, we're doing a problem. Notice we're given a function. F of x is 4x squared minus 2x. G of x is 2x. H of x is x plus 1. And we are going to be using those functions and doing some operations with them. So looking at number 1, what operation are we doing with f of x and g of x? We are adding them. There is an addition symbol between f and g. So another way we could write this would be f of x plus g of x. So another way to write this would be f of x plus g of x. So f of x is this equation, 4x squared minus 2x. Technically, this part is this expression. So this would be 4x squared minus 2x. Bring down the plus sign. And then g of x is the expression 2x. Now we need to add those two functions together. So make sure you start with the highest power of x, which would be x squared. That's the only one, so drop down to 4x squared. And combine your like terms. Negative 2x positive 2x is 0. So the answer is just 4x squared. So make sure your answers are in simplest form. Number 2, what operation are we doing with f of x and g of x? Subtracting them. So another way I could write this would be f of x minus g of x. So what do I put for f of x? 4x squared minus 2x. And what do I put for g of x? Yes, we are subtracting 2x. Now, what if I was subtracting 2x plus 1? What would you have to have there? You would have to have parentheses. So if you are subtracting, just keep that in mind. If you're subtracting something other than a monomial, you would have to distribute that negative. So just FYI, I just added that in there, because you may see something similar to that on your assignment, and I want to make sure I point that out. So this was f of x, and we are subtracting g of x, which is 2x. So since g of x is a monomial, I didn't put it in parentheses, but if it were a binomial, trinomial, put it in parentheses, distribute that negative. Okay, combine your like terms. Yes, the 4x squared would go first. Negative 2x with negative 2x gives us negative 4x. No, if you factor it, then it's not going to be in simple form. Okay, number 3, what operation are we doing with f of x and g of x? We are multiplying those two functions. I'm going to rewrite this as f of x times g of x. So for f of x, we have 4x squared minus 2x. And it needs to be multiplied by g of x, which is 2x. What operation does parentheses imply? Multiplication. So we're still multiplying. So distribute your 2x. What is 2x times 4x squared? 8x cubed. Distribute one more time, and what's 2x times negative 2x? Negative 4x squared. Okay, same function. Number 4, what operation are we doing with f of x and g of x? We are dividing these. I'm going to rewrite this as f of x divided by g of x. So f of x is 4x squared minus 2x. And what do I put for g of x? 2x. Does that No, we need to go ahead and divide those. So what is 4x squared divided by 2x? 2x. And what is negative 2x divided by 2x? Negative 2x minus 2. Number 5. How did this one change from problem number 1? They defined x to be what value? 2. So I can rewrite this as f of 2 plus g of 2. So f of 2 plus g of 2. So that means I need to go to f equation, and what do I substitute in for the x value? 2. So we need to do 4 times 2 squared minus 2 times 2. And that's f of 2. Then we need to add to that g of 2. So that means I need to go to g's equation, and what do I replace this x with? A 2. So this is 2 times 2. Evaluate that. So start with the exponent, and what is 2 squared? And 4 times 4. So this would be 16 minus 4 plus 4. What happens with your negative 4 and positive 4? Yes, they make 0, and the final answer would be 16. Number 6. How can I rewrite number 6? F of 3 minus g of 3. So we need to go to f equation and replace those x's with what value? 3. So this would be 4 times 3 squared minus 2 times 3 minus. Now for g of 3, go to g's equation, and what do I substitute in for this x? 3. 3. So we need to do 2 times 3. Take care of the exponent first. So 3 squared is 9. 4 times 9, 36 minus 6 minus 6. 36 minus 6 is 30, and 30 minus 6 is 24. Okay, same equation. Number 7, what operation are we doing with f and h? Multiply. So this can be rewritten as f of 4 times h of 4. So go to f equation, and what do I substitute in for the x's? Of 4, so this will be 4, and then 4 squared, minus 2 times 4, and that takes care of f of 4. And then this answer would need to be multiplied by h of 4, and for h of 4, yeah, this would be 4 plus 1. So inside another set of parentheses, I'm going to write 4 plus 1. Okay, so now we need to find f of 4. So 4 squared is 16. 4 times 16, 64. So this would be 64 minus 8. 4 plus 1, 5. What is 64 minus 8? 56. So this would be 56 times 5. And 6 times 5 is 30. 5 times 5 is 25. And 25 plus the 3 would be 28. So this answer would be 280. Next one. This one is called a of 1 inside the innermost parentheses. So we need to start with g of 3. So what we have to do is just drop down the f, and we're working inside the innermost parentheses first. So the first thing we need to do is find g of 3. So go to g's equation, and we need to do 2 times 3. And 2 times 3 is 6. So that leaves us with f of 6. So now I go to f's equation, and what do I substitute in for both of these x's? Of 6. And we do 4 times 6 squared minus 2 times 6. 6 squared, 36, and 4 times 36. 1/4 minus 12, and 144 minus 12, 136. Now just so I notice we have a function inside of another function. So this one is a composition of functions. It is not multiplication because we have a function inside the function. So when you have a composition of functions, start with the innermost function. So we need to start with f of 3. So drop down to g. And for f of 3, go to f equation and replace both of these x's with a 3. So we need to do 4 times 3 squared minus 2 times 3. Bring down the g. What is 3 squared? 9. What's 4 times 9? 36. What's 36 minus 6? 30. So now we need to evaluate g of 30. So go to g's equation, and what do I substitute in for x? 30. So we need to do 2 times 30. And 2 times 30 is 60. Okay, now we are moving on to some new functions. Now f of x equals square root of x, and g of x equals x squared. Now, number 10. Is this multiplication or is it a composition? This is a composition because we have a function inside of a function. So which one do I start with? The f of 3 or the g of 3? Start with the innermost. So we start with the g of 3. So drop down the f. And for g of 3, going to g's equation, we need to do 3 squared. And 3 squared is 9. So now we need to do f of 9. And looking at f's equation, we need to do square root of 9. And the square root of 9 is, technically it's plus or minus 2, right? Technically. Okay, I want you to try number 11. Find g of f of 3. Okay, for number 11, is this a multiplication of g and f, or is it a composition? This is a composition because we have a function inside of a function. So we need to first start with the innermost. So we drop down the g. First thing we should have done was f of 3. So this would be the square root of 3. Now I need to go to g's equation. And g's equation, I need to take the square root of 3 and square it. We're taking square root of 3, and we need to square it. What happens when you square a square root? They cancel because they are inverse functions. So when you square a square root, it cancels the square root. So this would just be 3. Square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. Okay, now for composition of functions, another way that you can write a composition of functions, you can use this symbol right here. Normally we refer to it as plot. So if you see that open circle, it does not mean multiplication. This means composition of functions. So the way that you read this would be f of, so that little circle means up. So f of g of x. So that's why they have thought. Because that O stands for O. So the function f is composed of the function g. Okay. And then another way to write it is the way that we were seeing it in those previous examples. So if you see solve, that means it's a composition of functions. So we are going to take the domain of g of x. So g of x is our innermost function. And what does domain mean? X value. So when I'm working this problem, I am going to input an x value. So when I put in an x, my answer will be what? A y. So once you work your equation, you will produce a y value. So range means y. So we put in an x, so x is our input. We produce an output, which is the range value. So the answer I got for g of x technically is a range value or y value. So the range value from g of x then gets put into f of x's equation. So the range from g of x now becomes the input for f of x, which would be our domain. So just keep that in mind when you're working with your innermost function. We are putting in an x, and our output would be a y value. So g's y value then becomes the input for f of x's equation. And then that will produce the range value for f of x. And what we're going to be doing next for the last problem is going to be finding the domain of composition functions. So for f of g of x, we're going to find the domain for those composition functions. So the three steps. Here's step one. You need to find the domain of the initial function. What does domain mean? X value. So find the x value for g of x. So g of x is just the innermost function. We rewrite this as f of g of x. So step one, you find the domain for the innermost function. Step two, you find the domain of the resultant function. Again, domain means x value. Now resultant, what is the root word for resultant? Result. So you need to find the domain of the result function. So whenever you simplify, what was the result that was produced? And then step three, the domain of the composite is going to be the intersection of the domain from the previous two steps. So when they talk about your final domain, it's going to be the intersection of these previous two domains. This just means it's going to be the value in common. So when they're referring to the intersection, it's just the value in common. Or the values that are the same. So any x values that are the same between the innermost function domain and the resultant function domain. Okay, I'm going to break these down step by step. Okay, so for this problem step, f of x is x squared minus 9. G of x is the square root of 9 minus x squared. We need to evaluate and determine the domain of the composition. So the first thing we need to do is evaluate. What does evaluate mean? Solve it. Find the answer. Usually it's going to be numeric. So we need to find f of g of x. I'm going to rewrite this as f of g of x. So if you 9 minus x squared. So I'm just replacing g of x with what it equals. Now I need to go to F's equation, and wherever I see an x, I need to replace it with g of x's equation. So this x right here needs to be replaced with the square root of 9 minus x squared. So taking this equation, replace it with what's inside the parentheses. So replace that x with square root of 9 minus x squared. And what we are substituting in for x needs to be squared, and then we need to have the minus 9 after that. Yes, ma'am? Are we supposed to find the domain of the x? The first thing they wanted us to do was to evaluate. And then next, after we evaluate, then we're going to determine that domain. So technically there's two answers here. We need to evaluate, and then we need to find the domain. Okay, so what happens when I square root? They cancel out. So this is just 9 minus x squared minus 9. Yes, sir?
What do you mean? That's a G. I mean, that's an X times 0.
Because this little circle over here,
Oh, yeah.
if you see this little circle, it means f of g of x. So if you see fall, that means it's a composition.
Mm-hmm.
So if you see that open circle, it's composition. Now if it was a closed circle, then it would be multiplication. Okay, so simplifying this, I'm going to drop down the negative x squared. And what happens with a positive 9 and negative 9? They make 0. So this result, this is called your resultant. And we'll need that for step 2 in finding the domain. So that's why you have to evaluate first so that you can find the domain of a composition. Okay, so as a reminder, going back, how to find the domain of your composition. Step 1, we find the domain of the initial function, which is just the innermost function. So we first need to start by finding the domain for g of x. I'm going to write, this is step 1. And we need to find the domain for g of x, which is 9 minus x squared under the square root. So we need to figure out what values can be used for x. Probably the easiest way for this one would just be to graph it. So what is this function right here? Semicircle. How do I know that's a semicircle? Yeah, I have the x squared under the square. So just a quick step. What would be the radius for that circle? The radius is 3. And what would be h say? 0, 0. So this is just a sketch, not going to do anything fancy. So the center of our circle is 0, 0. And what did we say that radius was? 3. And on this semicircle, are we drawing the top half or the bottom half? Top half. How do I know this is the top half? Yeah, that's not a negative number. So if our radius is 3, go left 3, go right 3, and go up 3 from HK. And there is a rough sketch of our semicircle. And make sure that for semicircles you don't include HK because that's no longer function. So there is our function. So for the domain, for that semicircle function, our x values go from what to what? From negative 3 to positive 3. And do I include them? Yes. And both of these have the square bracket. So that's step 1. You find the domain of the innermost function. Step 2. And if I go back, for step 2, you need to find the domain of the resultant function. Now, what did I say where the resultant was? Result. Well, we just got the result previously when we evaluated this thing. When we evaluated, what do we get? Negative x squared. So we need to find the domain for the resultant, which is negative x squared. And we're going to do a quick sketch of this one here. What's the parent function here? Quadratic, where's the negative, make it 2. Reflect over the x-axis. So quick step. Oops, that was not actually over. Okay, so we are wanting to find the domain for that resultant function. So if it keeps going left and keeps going to the right, the domain would be what? Yeah, it would be negative infinity to positive infinity. And here we really want to use the integral notation. That way we can see the intersection of these two domains. So then step 3, let me go back to what it said. And step 3, it says the domain of the composite is the intersection of the domain from the previous 2 steps. So for the step 1, we got negative 3 to 3 inclusive. Step 2, we got negative infinity to infinity. So now we need to look at those 2 intervals and find the values that they have in common. So what x values do both of these intervals have that are the same? Negative 3 to positive 3. So the domain for our composite would be negative 3 to positive 3. So you're just looking for the values that are the same from the 2 intervals from step 1 and step 2.
How would you use algebra to determine the domain of step 2?
What you would have to do is you would have to figure out, okay, what numbers can I put here and where? Well, most often you check negative, 0, and positive values. So if I put in a negative for x, can I square a negative and get an answer? A negative comes to negative becomes positive. So can I square a negative? Yes. And then after you check a negative, the next thing I would check would be 0. Can I square 0 and get an answer here? Yes. And then I would check a positive value. And if I put a positive value in for x, can I square it and get an answer? Yes. So you just test numbers is really all you have to do. Okay, next one. Evaluate and determine the domain of a composition. And then I see pause. Does this mean multiplication? No, this means, how would I say this? F of g of x. So I'm going to rewrite this as f of g of x. So evaluate first. So we need to get the resultant. So bring down the f, and I need to replace g of x with this equation. And for g of x, I replace it with square root of x. Next, I need to go to f equation, and this x needs to be replaced with what value? Square root of x. So this would be 1 over square root of x. Now, in Algebra 2, were you told that you could do stuff like that? No. What do you have to do with that? What is that process called? Rationalize. Rationalize the denominator. So to get rid of the radical in the denominator, multiply both the numerator and the denominator. That is square root of x. So 1 times the square root of x gives me square root of x. And in the bottom, square root of x times square root of x is just x. So we evaluate it. And remember, when you evaluate, this is called your resultant. So the result you got from evaluating is called your resultant. Okay, so now you find the domain of the composition. So step 1. You find the domain of the initial function, which is just the innermost function, which is g of x, and the equation for g of x is square root of x. And if you think about that parent function, square root of x looks like this. So what is the domain of the square root function? This would be 0 to infinity. Do I include 0? Yes. Now, if you said all real numbers, does it keep going to the left? No. It can't be all real numbers for that. Oh, I just put steps. This was step 1. Step, no. Okay, step 2. Step 2. You find the domain of the what? Resultant. So the result that we got from evaluating is square root of x over x. Now, for this one, is this a function that we readily know how to graph quickly? No. So this one you'll just have to think algebraically. So I know that when I'm dividing, I cannot divide by 0. I'm going to say x cannot equal 0. I'm just making some notes myself. So I know you can't divide by 0. So if you can't remember that, just make yourself a note. You can't divide by 0. Just for fun, if you want to put in your calculator, put in 5 divided by 0, and your calculator will say, no, you can't. So you can't divide by 0. Okay, so we checked the bottom. Another thing you need to do is check the square root. Now, again, I like to test numbers. If I put a negative, if I put a negative 4, can I square root a negative 4? No. Is any negative going to work? No, you can't square root negative. Can I square root 0? Yeah, what's the square root of 0? 0. So 0 will work for the top. And can I square root a positive? Can I square root a positive 64? Yeah. So in the square root, I can't square root what number? Negative. So up here, I know the x value would have to be 0 to infinity for the square root. But down here, we said that x cannot equal what? 0, because we can't divide by 0. So now I need to combine these two trains of thought. So for the numerator, we saw that you can't square root negative. So the only numbers you can square root would be 0 to positive. But in the bottom, you can't divide by what number? 0. So now combining these two trains of thought, instead of including 0, what do I have to do with it? Not include it. Yes, so this one, for the resultant, instead of including 0, we exclude it. So the 0 gets the parentheses. So this would be 0 to infinity. And then step 3 is to find the intersection from those two intervals. So what values do we have in common? 0 to infinity. And do I include 0? No, I cannot include 0 because it's not included from step 2. And I show one more. Oh, the fun continues. Okay, luckily these are evaluating. Number 14, reaching fog. Does that mean multiply? So what does fog mean? F of G of X. So I'm going to rewrite this. F of G of X. So bring down the F. We're working with the innermost parentheses. And what do I put for G of X? 2x. Then I go to F equation. And instead of these x's, what do I substitute for these two x's? A 2x. So this is 4 times 2x squared minus 2 simplify that, what's 2x when you square it? 4x squared, and 4 times 4x squared? 16x squared. Minus, and 2 times 2x would be 4x. Don't factor that, because then it's not simple as well. Number 15. I see golf. Does that mean multiply? No, it does not. What does that mean? G of f of x. So start with the innermost parentheses. So instead of f of x, I replace it with 4x squared minus 2x. 4 minus 2x. Next, I go to G's equation, and what do I substitute in for the x? 4x squared minus 2x. So I have the 2, and I'm going to put this in parentheses. 4x squared minus 2x. Is that in simplest form? No, make sure you distribute. And what is 2 times 4x squared? 8x squared. And 2 times negative 2x? Negative 4x. Okay, I want you to do that last one, number 16. You have h of g of f of x. Which one do you start with first? F of x. That would be innermost one. Okay, starting with the innermost function, we need to start with the f of x first. Replace the f of x with 4x squared minus 2x. Next, we need to do g of 4x squared minus 2x, so drop down to 8. I need to go to G's equation, and wherever I see an x, replace it with what's in parentheses. So for G's equation, we need to do 2 times all of this. So we do 2 times 4x squared minus 2x. Distribute that 2. What is 2 times 4x squared? 8x squared. And 2 times negative 2x, negative 4x. Last step, go to H's equation and replace the x with 8x squared minus 4x. So that would be 8x squared minus 4x, and then put the plus 1. Is that simplest form? Yes, there's no less.